Hello and welcome back to the channel. Today we're going to be continuing our Arduino for Beginners series, and we're going to be having a look at buttons as inputs, and we're going to have a first look at the serial monitor. Hello and welcome back. Okay, so as I've said, we're going to have a look at using a button in our Arduino sketch to change the state of an output, and we're also going to have a quick look at serial monitor and how the Arduino can send information back to the computer. It's actually a two-way street, that communication, but we're just going to have a look at information coming from the Arduino back to the computer in this particular video. So as you can see, we have the same sketch here that we started in our last video. Now if you haven't watched the last video, I'm going to leave a link up in the top of the screen now, and also in the video description, to the series of videos we're doing here. So if you haven't seen the first two, go ahead and watch those, then come back and look at this one. So as you can see down over here, we've still got this this green LED flashing away that we did on our last tutorial, and here is the script for it. So let's have a think about adding a button into this. So let's say we wanted to add a button whereby the LED would only do this flashing sequence if the button has been pressed. Okay, so the first thing we want to do is define a pin that we're going to use for our button. So this is going to be a constant integer again, so it's going to be a constant value. So const int, and we're just going to call this button. Oops. No, try that again. There we go. And for this, we're going to use pin 6. Now it doesn't matter really which pin we're going to use, because we're going to be looking at the serial monitor later on. I'm going to avoid pins 1 and 2, 0 and 1, because they're the transmit and receive pins for the chip. So it doesn't really matter what pin you use, but we're going to use 6 here. The next thing we need to add is another integer, but this one's going to be variable, and this is going to be the state of the button. This will make more sense as we go on. I'm going to call this button state, and that's going to equal to 0. Okay, so this is just an integer. It's not a constant integer, because this value of 0 will change depending on the digital read of the button state. But at the moment, we're just setting this button state initially to 0. Hopefully that'll make more sense as we go on. Next, in our void setup, we're going to go pin mode. And we're going to say that our button is an input. So we're defining that the button is an input. Okay, so far we've said that we're using pin 6, and we're calling it our button pin, and that is a constant value, it's not going to change. We've also defined button state, and we've said that this is a value that can change, but at the moment we're setting that value to 0. And we've said that our button pin is an input. So next we're going to go down to our void loop, and we're going to add in here button state. And our button state, so what do we want it to be? What do we want button state to do? So when we refer to button state, we want it to digital read, right? We want it to read the value of the button. So digital read. And what do we want it to digital read? We want it to digital read our button pin that we called button. Hope that makes sense so far. So when we make reference to button state, that's going to digital read the pin that we've defined as button and change the value of that button state depending on what the digital read result is. So it'll be the digital read result will be 0 for low or 1 for high, because this is a digital read. Okay. Next, we're going to say, you know, what do we want to do? What do we want our button to do if it's showing as high? And to do this, we're going to use something called an if statement. So we'll come down here. So we're going to say if button state equals high. So if the button state equals high, do this. Okay, and you can see it's put our kind of open parentheses and closed parentheses there, but we're actually just going to take what we already had here, cut it out, and we'll put it in there, like that. Okay, so now what should happen is when our code loops, we'll see if our button state equals high, or another way to say that would be if our button state equals 1 after it's done this digital read, it is going to execute the rest of the code. If it's anything else other than high, it won't execute what's in here, i.e. the LED will remain off. So let's go ahead and verify that. Oh, here we go, I've made a mistake already. Button state was not declared. Have I made yes? Put a buttons state. So let's have a look at that, and as long, yeah, okay, so that's compiled and it's done. Let's just come over here and have a look at the hardware very quickly. So you can get little buttons that sit on your breadboard that you can press for prototyping, and I don't have any. I do have some, I just can't find where they are at the moment. So instead, I was going to use one of these little kind of momentary switches we've got here, and I was going to rig that up with some alligator clips and so on, but it was all just getting a bit messy. So what I'm going to do instead is, we've already defined that our button is on pin 6. So we're going to pull pin 6 out on here. So pin 6. And we're just going to plug that in here. Now what we need to do with pin 6 is we need to pull pin 6 to ground. So what that means is we need to put a 10k ohm resistor on pin 6 onto ground. And that means when we're not applying 5 volts, when we're not pushing the button, the pin is pulled all the way to ground. If you don't do this, the pin doesn't get pulled all the way to absolute 0, all the way to ground. It kind of floats around, and you'll get some results that aren't desired. Basically, LED in this case may or may not turn off, or it might flicker. So we've got a lead coming out of pin 6 into the board here, so this would normally be our button here, but we're going to go put this 10k ohm resistor between pin 6 and ground. We've already got a ground rail running here, and then to simulate our button, I'm just going to pop this on this side here, and we're going to pop that into the 5 volt rail, this one. And I'm going to pop this yellow cable in here. Now, when I plug this yellow cable into this same row here that's on 5 volts, that's just going to simulate me pressing the button. So in normal circumstances, I just have a button in between here, but I don't have that. I'm just going to use this wee cable to press the button on and off. I hope that makes sense. Sorry, there's a lot of light coming through my window all of a sudden now, so it's going to be a bit harder to see this. I'm going to try turning my light up here, see if that makes any difference at all. Probably not. Right, so we'll go ahead and we'll upload this sketch. And you may see the upload lights flickering away there. Okay, and it's saying it's done uploading. And you can see that our LED isn't on at the moment. So let's go ahead and plug our yellow cable in, like pressing the button, and you can see now the green LED is flashing. So let's take our finger off the button and it stops. So we can see that this code here works. Okay, now that's all fair and well, but you probably don't want to do that. There's not much function you're going to get off having a button that you press and make an LED flash. Although it is quite entertaining the first few times you do it, it doesn't have much function. So let's say actually what we want to do here is we want to take a switch like this one I have here, and we want to make a door sensor. So when the door is closed, we want the green LED to be lit up, and when the door is open, we want the red LED to be lit up. There's obviously a few applications for this. You know, a sensor that your fridge door's closed properly springs to mind. But let's have a go at writing the code for that. So the first thing we need to do here is define another LED, or red LED. So that's going to be another constant, and we'll call this one red LED. And we'll put red LED on pin 8 because why not? Okay, next we want to come down and put pin mode. We're basically just copying here what we have for the green LED already. Red LED, and it's an output. Now, what we want to happen here, so we want our green LED to be on if the door is closed, and we want it to be off and the red LED on if the door is open. So we can get rid of our delay because we don't want anything to flash. So let's delete that. So if our pin is high, our door is closed. So if our button state is high, we want our green LED to be high or on. But we also want our red LED to be off. So we'll digital write red LED low. And that's great, it'll do that. But what if our button state is low? So what we can do here is we can use what's called an else statement. So we're saying if our button state's high, do that. But for everything else, so if it's in any other state, do this. So else, and then I'm just going to take the code we've already written here, copy that, and paste it in here, but change the low and the high around. Okay, so just to go back through this, what we're saying here is if our button state is high, green is on, red is off. For any other state, so if our pin is low, then green is off and red is on, simulating a door open or being closed. Let's jump back over to the hardware here for a second, and we'll have to set up another LED. So we've set that this one is going to be on pin 8. So we'll put our wire here into 8. Oops, bumping the camera. And we'll plug that in up here. And then our LED. And then a resistor to ground. So you can probably tell I've got a limited space here, unfortunately. Okay. So let's go ahead and make sure our code is good. And yeah, that seems to be working as it should. So let's go ahead and upload that. And we'll see our upload lights flickering away there. And upload has been successful. Now you may or may not be able to see that the red LED is on. So if we go now and we push our button, our red LED turns off. and our green turns on. I hope you can see that. I can see it on the screen here. Hopefully that'll come out. So push the button, so that simulates our door being closed, open, and it turns red. You can do it quite quickly. Keeps up. Okay, excellent. Plug that in. So that's obviously a very basic example, and you can extrapolate that out to as big as you want. But that's the basic function of an input having an effect on an output. The other thing I just want to quickly touch on today is the serial monitor. So serial monitor is used as a way to communicate between the Arduino and the computer, or indeed the Arduino and another device sometimes. But let's say in this example we wanted to be able to see in text on our screen if our door was open or our door was closed. Now this could be done on a small LCD screen. I'll flash an image up on the screen now of the kind of thing I'm talking about. And these are quite common in Arduino projects. Unfortunately I don't have one. I'm definitely going to order one for the rest of this series. So for now we'll just be using the serial monitor on our screen. But there's a few things we need to do here in the code to get that working. First thing we need to do is in our void setup, we can go serial.begin. So that's going to open up our serial port, tell it that we want that serial data. If we don't do that, there's no data being shared between the Arduino and the computer other than uploading the new sketch. So you need to tell it you want it open. And you need to set what's called a baud rate, which is basically the rate at which information is being sent. The kind of standard's 9600, but there is more options, but for now we'll just say 9600. Then we can come down to our loop, and in here, so when our button state is high and our green LED is on, means our door's closed, right? So we can say serial.print. Now if we do serial.print and leave it at that, that means that when our data is being printed into our serial monitor, it will just all be on the same line. But if you put serial ln, each time that a bit of serial data is printed, it'll come down onto the next line. It's a bit easier to read. And in here, we're just going to say door closed. And then we're just going to copy this here. And we're going to do the same down here for when our door is open, but change it to open. So we can go ahead and verify that everything's okay with that, which it is, and we'll upload our sketch again. You may or may not be able to see that this LED here is now lit. Now that's our transmit LED, so we know that our Arduino here is transmitting out data, so that's a good sign that things are working. If we jump back over to our computer here and go up to Tools and Serial Monitor and give it a second, we can see now that it's telling us our door is closed. Now that sounds right, because if we look back over here, our green LED is on and our button's being pressed. Now if I pull this cable out, so I'm taking my finger off the button, you'll see it changes over to say doors open, plug it back in, closed, open, closed. And that's all there is to it. We are going to get a bit fancier with the serial monitor. Obviously this is a bit, not the most elegant way of doing it. We're getting that door closed each time the code's looping. What would be nicer is if we just had door closed once unless the state changed. And we'll have a look at that going forward. But I'm going to leave this one here now because we're over 20 minutes by the looks of things. So I'm going to leave this one here, but if you have found this useful, please do go ahead and subscribe. That's really helpful for the channel. Leave a like and put a comment down in the description, and hopefully I'll have more of this series to come very soon.